Good day, everyone, and welcome again to our webinar presentation. My name is Adam Harris, Managing Director at C-Therm Technologies. Very pleased to welcome you to our feature presentation today. We've been running these webinars on a weekly basis over the past few months. We've curated a number of topics. They're educational webinars by nature, highlighting different aspects of thermal analysis. Our particular niche at C-Therm is in thermal conductivity, but we work closely with a number of other groups around the world, including Metravib, which is part of the ACOM group, the world specialist in DMA, dynamic mechanical analysis. And so today's topic is featuring the automation capabilities to increase productivity in DMA analysis. And we have an expert with us today, Hugues Boré. He's the International Sales Manager for ACOM and heads up specifically the DMA group there, and it's in terms of the global sales of it. So really pleased to have Hugues with us on the presentation today. The presentation should run for approximately 1 hour. We will reserve some time at the end of the presentation for a Q&A. We also have a great little video to show you that really gives you eyes on what this looks like in terms of the automation Xpander platform. It is really cool. We're excited to share it with you today. If you have any questions or comments as we go through the presentation material, do take advantage of the chat box feature. It's a great way to register any comments or anything you'd like us to delve into a little bit deeper. If we don't catch it in the live presentation, we will revisit that chat log in the Q&A session as well. So that's a great way to interact with us and to certainly register any thoughts or comments or questions with us that you'd like us to address. So I want to just offer a little bit of background on who C-Therm Technologies is. I see a number of familiar faces online with us today, but I also see some groups that may be newer to who C-Therm Technologies is. So C-Therm is a niche player in thermal analysis. We are experts in thermal conductivity. We advance and innovate on the topic of thermal conductivity measurement. Our goal and raison d'etre in life is to simplify and improve the measurement of thermal conductivity. And we do that by focusing on transient-based methods for thermal conductivity. We've patented a number of novel techniques for measuring conductivity, the most popular of which is the modified transient plane source sensor. This is a single-sided sensor that you see pictured in the on screen right now. This is employed across a broad range of industries, from polymers, rubber, nanocomposites. We work a lot with phase change materials, explosives, all kinds of different industries and spaces. And the core product from us is just recently launched last year. This is representing about a 13-year journey that we've been on in terms of developing instrumentation, and this is the pinnacle of that research. It's Trident. It brings together the three most prominent, powerful capabilities in transient thermal conductivity. Our patented MTPS sensor, complemented by the robust needle sensor. That's the stainless steel needle that you see in the middle there, and as well as the hot disk style transient plane source sensor. That's the yellowish sensor. It's a nickel foil. It's encapsulated in typically a polyimide and sandwiched in between two samples. This is called our Flex TPS sensor, and it really gives you maximum flexibility as a user, has some very advanced capabilities, including the ability to test anisotropic materials. So if you're in polymer composites and your materials are oriented, we have the ability to characterize that difference in thermal conductivity performance that's directional dependent with Flex. But really, as a platform, this is a very powerful capability, one that future-proofs your lab to deal with a broad range of scenarios. So that's called Trident, and that's the short little video I played on the intro. We're not going to talk much more about it today, but if you are interested in learning more about Trident and thermal conductivity, just enter it in the chat box, and we'll make a point of sending you some additional resource materials on Trident. C-Therm Technologies, we are a global manufacturer and that niche specialist in thermal connectivity, but we also have a number of partnerships where we help and support clients locally in North America in representing some other really high performance equipment. And that's what we prefer to align ourselves with, is groups that are doing really interesting, novel research and development in the area of thermal analysis and thermal characterization. So one of those groups that we represent here in Canada is C-Therm Instrumentation. We've been working with them for over a decade. They're the global leader when it comes to high sensitivity, high temperature calorimetry and thermal analysis, including TGA, DSC. They can get into combined systems. They do a lot of absorption work, gas absorption work. Really impressive capability line, and they've really driven innovation in that overall sector of calorimetry and developing a 3D sensor, which is about 3 to 4 times more sensitive than a typical pan type DSC. So if you're interested in measuring the heat capacity or related applications in thermal analysis, we'd also be happy to share some of that expertise if you want to register that thought or interest in the chat box. But today is all about dynamic mechanical analysis, and specifically, how can we automate it? How can we drive increased capacity? We've launched a new partnership with Metravib. This is an ACOM group. We're really excited about this because they bring some really powerful technology, and we're excited to provide both pre and post-sale support in working with them and supporting their clients and our clients in North America. So this is something that was new, launched just at the beginning of the year, and really excited to have Hugues Bourrier online with us. At this point, I'm going to stop sharing my slides and ask him to bring up his slide deck, and we'll get to the main event, the star of our show, to talk a little bit about the Xpander platform for Metravib.
Thank you, Adam, for this nice introduction, and welcome everyone to this presentation focused on the automated DMA. I have a little problem about the sharing. Okay, now it's okay.
So we're just bringing up the slide deck here. There we go.
Yep.
Great. Okay.
Here it is. So as an outside, so I'm in charge of the Metravib international sales, and the time being, I'm quite stuck in France without any possibility to travel. So it's a great pleasure for me to have this possibility to introduce our product through this webinar, because it's the new way in the new world to travel. So let's first do a short introduction about ACOM for all the people who are not familiar with us. So the company ACOM is based in Lyon. The headquarters is in the west suburb of Lyon, and so we are 750 persons worldwide, based in different subsidiaries in an office, with a global turnover roughly around 100 million euro, and our distributor network is around 150 companies, partners, everywhere in the world for the different activities. We have, in fact, 4 different activities. So in environment, so for the prevention and control of air, noise, and vibration. And you have noticed that recently the air pollution improved very much according to the reduction of global traffic. This kind of measurement is made with some of our instruments. Aquem for the maintenance in the industry, and so we supply instrument and service to improve the reliability of the industrial machinery, and especially rotating machine in doing preventive maintenance. We will focus on Metravib design just in a few minutes. And a first activity in the field of defense consists in protecting soldier vehicles and sensitive sites, in detecting gunshot by acoustic method. So 4 different activities, but having in common the measurement of noise or vibration. So regarding Metravib design, so we are focused on the R&D service and supply of testing solution for industry, with 2 different activity. One activity in noise and vibration engineering, so focus on the design and helping company to design, produce robust and noiseless. So in many different fields, transportation, aerospace, oil and gas, engineering, generally speaking, industry, and as well in the energy field. And we supply as well expertise in the field of noise and vibration engineering, so helping a company to develop product comfortable, silent, or sometimes solving some very hot problems on new products, like a coffee machine doing too much noise, or like a rocket providing too much vibration in the launching, for instance. So we work in many different fields to improve the quality of life, in fact. Regarding the material testing activity, and I will focus my presentation on the automated DMA. So we provide industry and research lab with dynamic mechanical analysis instrument, so for the characterization of the viscoelastic properties of material and the thermomechanical properties of material. You can see here our DMA instrument product range with 2 main series, the desktop series, that are, let's say, traditional DMA with low force excitation. So DMA 25, DMA 50. So that's very cost-effective product, desktop product that give already a very good testing solution for, especially for determining glass transition and obtaining some behavior of the material depending on many parameters. And beside the DMA+series, which is a very unique DMA range with high force capabilities, with different model, DMA+ 300, 1000, 2000, which correspond to different level of force based on the same architecture, and making possible to address much larger testing capability for the viscoelastic properties analysis of many different materials in a very large range of analysis in terms of force, strain, temperature, environmental condition. This series can be connected with different add-ons that extend the capabilities in terms of productivity. So that's the subject today with the automated DMA, or for extending the test capabilities to fatigue testing with specific software, multi-test, that make possible to address from classical fatigue testing until more specific heat buildup testing or crack growth testing of rubber compound. And at last, the VHF 104, which is a very unique product focused on the high frequency testing, direct high frequency testing, and making possible to address direct measurement up to 10 kilohertz, while, let's say, traditional DMA stop around practically, theoretically 100 hertz, but practically 50 hertz for most of the traditional DMA, except for the DMA+ Metravib, where we can reach 1 kilohertz in some configuration. The VHF is a very unique instrument to address a very high frequency range for rubber materials. A short overview of some big name among our customer to give you an idea of who is using our product worldwide. So you can see a big name from rubber industry, for polymer industry, chemical industry, so automotive, aerospace, other transportation, and from as well some very influent university as well. So a good demonstration of the large application field of our product. So if we first focus on the key DMA specification, but you will see that this is a major focus necessary before to address the automation aspect of the dynamic mechanical analysis. It's important to first to share, but I think that if you are already involved in DMA, you are already aware of the basic DMA principle, but just a short reminder. So we have generally a mechanical test frame, an electrodynamic shaker that provide the vibration, a force vibration to a specimen of material, and a measurement of deformation of the material, measurement of the force transmitted to the specimen, that are corresponding to the two basic information used to compute first the stiffness of the specimen, which, taking into account the test mode and the shape factor, lead to the computation of the Young or shear modulus, depending on the excitation mode, and lead to the measurement of tangent delta, which is one of the key parameter of the DMA test. So the key specification and parameters for the DMA testing are a lot, in fact, and all of them are critical. And so the first one, and probably the most important, is the mechanical design, because we are measuring with the DMA the stiffness of a specimen, and this stiffness has to be quite low compared to the mechanical to the stiffness of the mechanical test frame. That's the first very important condition. So the stiffness of the frame is a specific key feature, and you will see how we deal with this with the DMA+ series. But it includes as well all the mechanical parts in the excitation chain and all the interface that are connected to the specimen. So the specimen holders, so all mechanical parts in line with the specimen have their influence in the measurement. The transducer, the metrology is very, very important for measuring the force and for the displacement. The thermal conditioning as well, because the viscoelastic properties of material are very connected to the temperature conditioning. So the temperature performance of the thermal chamber and the accuracy of the temperature measurement are parameters of first importance. Signal processing, of course, the control algorithm that ensure to handle the wished excitation condition are something that are especially important because the quality and the accuracy of the test will totally depends on the stability of the excitation control and the accuracy of the amplitude control. Specimen preparation is as well very important because the computation of the data. So any piece of material can be tested with the DMA, but the geometry of the specimen is something really critical, and the dimension measurement as well, because they are of course part of the parameter used for the calculation of the Young or shear modulus, and a mistake on the dimension or on the shape will directly affect the data you can provide with the DMA. And last but not least is the operator effect, which is sometimes a very important parameter in the robustness of the data, the reliability of the data, the repeatability and reproducibility of the data. So in conclusion, the satisfying data accuracy can be obtained only if all those parameters are well handled. So the DMA technique is a fantastic technique, but all these parameters have to be handled very strictly. The DMA+series is the most recent series in our product range, and is designed to be the NEC plus ultra, the very high-end DMA solution with impressive performance. And the first reason is the care we took in the DMA plus mechanical design. So the mechanical test frame is based on a one-piece part to give an extremely high stiffness to the system. So ensuring that we will be able to measure the stiffness of any specimen that can be measured with the system, to ensure that the deformation of the specimen that will be measured correspond effectively to the specimen and not to the mechanical test frame. So this high rigidity test frame imply a very large frequency range in terms of testing capability. So because the resonance of the frame is much higher than 1 kilohertz, and then the usable frequency range can be much larger than let's say classical DMA. Another consequence of this design is the large measurement range in terms of stiffness variation. So this test frame makes possible to follow up the variation of stiffness of a specimen over up to 6 decades. And here, the principle of the system is based on the fact that the specimen is attached in one extremity to a fixed point of the frame, and in the other extremity to the shaker that provides the excitation, so conform to the ISO 671 standard. So the transducer selection in terms of technology and range make possible to have a very linear measurement over the large force range, and accurate measurement as well as very low force level as for very high force amplitudes. So regarding the displacement, we have also a specific technology developed by our engineers team for obtaining very accurate measurement as well in a large range of displacement at low amplitude and high amplitude. So covering up to 5 decades displacement range. The advanced control algorithm are something very very important in the management of the DMA test. For each point, it's the algorithm we developed make possible to avoid any overshoot in terms of amplitude, and this is especially important for nonlinear material to never exceed the amplitude that is defined as a setting value. We offer a full traceability of the excitation applied to the specimen from A to Z during the test, and the control tolerance is adjustable to ensure to obtain the good performance according to the accuracy that is expected from the test. So all these algorithms are really key parameters to ensure that the wish conditions are really applied to the material. And this is a big difference that offer the DMA+series compared to, let's say, traditional DMA, where the conditions really applied to the specimen are quite often not really respected. The thermal conditioning, of course, is also critical, and so we developed a very performant temperature chamber and advanced temperature calibration that make possible to ensure that the measurement obtained for the temperature correspond to the temperature seen by the material. And this is not so obvious according sometimes to the size of the specimen that can be sometimes big. And then it's important to have specific calibration for those specimens to ensure that the temperature inside the specimen is really controlled and known. The last point is relative to ergonomics, and this is especially important for operator, of course, but it's also a key for the productivity. In the design of the DMA+series, no hardware has to be exchanged to achieve the test and to cover the whole analysis range. So in terms of frequency, force, displacement, so it's very important. All the transducers are included in the system, and so that means that a frequency sweep, for instance, can be swept from low frequency to high frequency without having to change any hardware, any transducer. And so that makes possible to do continuous tests in a single shot, whatever the range of analysis is. So the design of the mechanical test frame is done in a way that it gives a very free access to the specimen and a very important comfort to the users. And you will see that is a link with the focus of this presentation. The design of the chamber has been specially made to make it to make the system open to the coupling with the automation system. So the DMA+ major benefits come from very specific design, and the result is data accuracy that is ensured even for stiff specimen, and so especially important on the glassy plateau and for rubber material, especially we have some time to deal with very stiff material at low temperature. The test requiring large strain and stress range, high frequency testing capabilities, especially above 50 Hz, where the conventional DMA start to be very weak, and the follow-up of material featuring large modulus variation over the temperature range in one single test is also a high benefit of the DMA+ range. So it's very important to understand that the tire industry is a special market driver for the DMA, and especially automated DMA. So that's the introduction necessary to understand why we offer automated DMA, and what has been the target in such development. So the tire industry is a great consumer of DMA testing. So we are supplying tire company for more than 30 years, and I think Goodyear was the very first customer of Metravib for the DMA activity, and in tire industry, DMA is become a major testing technique for testing intensively rubber compound and give key data that are used for the prediction of tire performance, for the rolling resistance, for the wet grip, so for performance that are already displayed on the label of the tire, and that are important predictor shared by all the tire industry and their suppliers, chemical companies and provider of different components. So the characterization in temperature, in frequency, the analysis of pain and Mullin's effect, so the nonlinear behavior of the rubber compounds, heat buildup, as well fatigue crack growth, are very common tests performed with our DMA in the tire industry. But at the same time, a majority of the company are using classical instruments, so manual instrument, and doing tests specimen by specimen, which represent a huge consumption of operator time, and also an important factor of data dispersion. So for more current tests, the test duration is in between 30 minutes to 2 hours, let's say, depending if a strain sweep or a temperature sweep or a frequency sweep. Okay, and that make necessary the intervention of operator every 30 minutes or every 2 hours to change the specimen and launch the next test. So of course, nighttime and days off represent a huge loss of testing capabilities because the system keep doing nothing. Okay, so we addressed already the need to improve the productivity in this field a long time ago in the year 2000, and we proposed already some system, but at the time, so the name of the product was ROB 100, and the system was dedicated to a single test mode. That's something you can see here on the picture of a lab of a tire manufacturer. And you can see plenty of instrument here with an automated system, but totally dedicated to shear. So in fact, the tire industry demands change a lot in the recent years, and the expectation from the tire industry has been expressed in three major axes. So that data accuracy, so pure accuracy, repeatability, reproducibility. So the DMA data that are used in models for the prediction of tire performance, of course, require the greatest accuracy possible. And also the use of more and more DMA units in the same company, in the same lab, or worldwide in different labs, implies to get a good cross-checking of the data between the different units in the different labs. The flexibility, the DMA instruments allow to run different tests, and it's supposed to be very flexible for temperature test, frequency, strain sweep. The descriptor that has been defined by the industry used sometimes different excitation modes, so compression, tension, shear, depending on the choice of the lab, depending on the history, sometimes depending on the capability to provide the specimen and to prepare the specimen. The test should be possible as well for new compounds, so where anyone can define a mold and define the specimen geometry, or as well for specimens that are taken out from a tire. So then the constraints is very different in terms of geometry and dimension, depending on the design and the size of the tire. And the last but not least, the productivity, the lab test demand is more and more important. So the use of the DMA is more and more intensive, and test during nights and weekend are highly expected to optimize the test lab throughput. So let's introduce Xpander, which is a new fully automated DMA testing solution. And the target of this product is really to meet the expectation of the tire industry in terms of data accuracy, in terms of repeatability, reproducibility, flexibility, and productivity. So the technical requirement of this product has been really made after a long exchange with the leader of the tire industry to take into account all these expectations. So the result is a very unique combination of a DMA, which corresponds to the DMA+ I just introduced, and a six-axis robot. So you can see on the right the DMA+, and on the left the Xpander system. So including the robot here, which is a tabletop industrial robot, a magazine, a carousel magazine, including up to 12 removable storage racks, making possible to include up to 3 test modes, so in shear, compression, and tension, that are mixable in the carousel with different autonomy. The system can store up to 444 specimens in shear, 408 in compression, and 108 in tension. These numbers are for compression and tension may depend on the dimension of the specimen. And this design is totally adaptable and upgradable according to the lab needs and easily customizable for the test mode combination or the specimen geometry. And here is the robot control unit, which is driven by the DMA suite software multitest. So the Xpander is really a booster, in fact, to boost the DMA+ testing productivity. And so the requirement, the original requirement for this robot was very strict and made in the way to avoid any restriction in the capability of the original DMA. So all the testing capabilities of the DMA+ are preserved. So as you can see, the system is set beside the DMA+. So it is very easy to couple this robot to a system that is already installed in a testing lab. The robot technology is what is called a collaborative robot. So it means that it is a very friendly robot with no risk for the operator if the movement are done under a certain speed. So it means that the system is really compatible with an operator sitting beside without presenting any risk, and so without making necessary any security fence. So it doesn't represent any additional requirements for the installation. It uses only compressed air and electricity as the DMA+ does. And the footprint is quite limited. It's 80 centimeter by 60 centimeters, so let's say the size of a washing machine. So it doubles more or less the footprint of the DMA. So the flexibility is very high as we can combine 3 testing modes for shear, compression, and tension. So the 3 modes can be mixed on the same single machine, and the configuration or the reconfiguration from one mode to another one is quite fast. Under 15 minutes to exchange the specimen holder and calibrate the robot so that it could be identified the location very accurately, the location of the specimen holder to load the specimen. So the DMA+ can be used in a fully automated mode, or can also switch to a classical manual mode. So it's according to the design, it's quite easy to continue to use the DMA without the robot if there is any need for R&D work on different geometry or different configuration. And then as well, the reconfiguration from the automated mode to the manual mode is also limited in terms of time, below 15 minutes. So in shear, the system use what we call the Rod 100 standard. So this is the most used geometry in the tire industry, used in the former instrument we produced a couple of years ago. And this geometry is based on a very long experience in automated shear. So the dimension or in diameter here is 10 millimeter, and the thickness of the rubber part in between the metallic part is up to 12 millimeter. In compression, here you can see the specimen is up to 26 millimeter with a diameter up to 18 millimeter. And the system is compatible even with very small specimen, so below 10 millimeters. Sometime specimen taken out from the commercial tire trades are in the range 5 millimeters, 6 millimeter height, and is totally compatible with the loading system of Xpander. And regarding tension test, so the test can be done on sheets, strips, films, cords, up to 3 millimeter in thickness, 60 millimeter in height, and with maximum width of 30 millimeter. So you can see here the three-step of the process. So the gripping of the specimen, the loading of the specimen, and the clamping of the specimen. Here the example is a tension test. After this presentation, I will show you a short video, 3 minutes, showing the system in operation that will be much more relevant, and it will be more impressive. Of course, all this design is based on a very smart clamping design that we made already 20 years ago for the first shear automated testing machine. And well, the design is made to reach very high stiffness of clamping to get optimal data accuracy, to be very light and making possible high frequency testing capabilities, to be very robust and highly reliable. And we get a very long experience in this field which prove this. So the technology is really smart and really efficient. The data accuracy, and as I said, the efficient clamping is one of the key to preserve the accuracy of the DMA+. And all the data, the performance correspond to the nominal performance of the DMA+series. So everything is preserved, the accuracy in terms of the viscoelastic properties measurement, the repeatability, the capability as well following low strain and high strain tests, high frequency testing as well. As well, no hardware handling to cover the nominal analysis domain of the system. And of course, all these parameters ensure a very improved correlation of data between multiple DMA units. And that's mainly the benefit of the DMA+ test frame design, which limit a lot the impact of the association of several mechanical components in the mechanical test frame. Of course, an automated DMA offer a very extended productivity. So the system is designed for continuous intensive testing all day and night long, and all day of the week, all week of the year. So the limitation correspond to the exchange of specimen, calibration, and the system can be used. And we have some feedback from customers using the system more than 95% of year in a continuous way. So the easy access to the machine, and so it's something really comfortable and efficient, so which does not require any lost time to open fans and so on. Routine tests can be easily programmed for all specimens of the magazine. So various tests can be combined and chained for each specimen. So it means that for one single specimen, you can chain a temperature ramp, a pain effect test, a frequency sweep. The combination of tests is really free and flexible. A test campaign can be interrupted to give priority to another one, and because that's real life case for tire manufacturer, and so it's quite easy to complete the former test campaign later. The racks storing the specimen can be fed with a specimen outside of the carousel to avoid to lose some testing time. The same machine can be configured for shear, compression, and tension in automated mode or in manual mode. We have also a function with called operator alert that make possible to warn the operator by a text message or phone call or emails in case the test is finished or interrupt, and that make possible to avoid to lose too much time without testing. And the system is highly reliable and require low maintenance. In fact, we have for the robot parts only one, let's say, actuator, which is the robot. No other actuator but the robot, which correspond to a catalog product which is used intensively for numerous industrial applications in various industries. Clamping technology is experienced for a long time with a very high success, and we have the testimonial of numerous customers in this direction. As I said, no additional actuator for the carousel or for any movement of the robot. And the electrodynamic technology is not sensitive to the number of excitation cycles. So it's historical facts. Using 3 times more DMA doesn't reduce its lifetime, and that's a very important feedback we get for 20 years now from the former automated range of Metravib DMA. So let's have a look on Xpander performance. And so first test here correspond to 50 consecutive tests at room temperature. So the goal is to express the DMA measurement intrinsic repeatability, and you can see that the standard deviation we can get on the stiffness we measure is roughly 0.01%, okay, and on tangent delta 0.28%. So in this case, the specimen is a metallic specimen with let's say a middle range stiffness, and that gives already a very good idea of the performance of the system. If we look at a rubber compound with 20 consecutive tests without moving the specimen, so without loading, uploading, and downloading the specimen, So the specimen is fixed in the specimen holder, and you can see that we get the same order of performance. Standard deviation is roughly 0.001%, and tangent delta 0.16%. If we look at the same test, but with uploading and downloading the specimen, okay, we have a small increase of the deviation, which means that the positioning will have some importance in the response. But you can see that we get 0.2%, 0.2% on tangent delta and stiffness measurement. If we look now some tests performed at variable temperatures or typical temperature ramp test. So you can see here the result from 4 consecutive tests with the same specimen, okay, and uploading and downloading the specimen between each test. And you can see here the 4 curves superimposed on the same graph, so which is already determining in terms of capabilities. And you can see that depending on the temperature, you have here some different standard deviation from 0.3% up to 3% in the glacier region, 2% in the glass transition region, 2.1 in the glacier plateau. So, of course, on the glacier plateau, that's the more difficult range in terms of stiffness, because we reach very high stiffness, and that's where also the repeatability of the test is a little bit less good than in the glacier transition region, but still very, very important. And here another test. So in tension mode in this case, so with 3 consecutive tests as well on a temperature ramp test to give an idea. So here we have much softer specimen than shear, of course, and you can see that the standard deviation we can get on the stiffness is inferior to 1%, and as well for tangent delta. So the best conclusion is the feedback we can get from our customer, and here we have the testimonial from Solvay. So Solvay is a leader in his field. So his field is silica. Silica is used as instead of carbon black to optimize the performance of tires, or improving the rolling resistance of the tire and the wet grip performance. So for such activity, the DMA testing is really a key analysis to demonstrate the performance of the Solvay silica. And so Solvay is using Xpander system to improve the productivity of the lab, and express that they noticed a very significant saving in the use of the system. So as a conclusion, so Xpander is really meeting the industry expectation in terms of productivity gain, in terms of data accuracy improvement. And so this lead to optimize the ability to clearly distinguish and rank the material formulation. So it's also a configuration that give a very satisfying solution regarding the operator effect, because the operator effect is very limited with such automated DMA configuration. And the repeatability performance mainly depend on the respect and the careful definition of the test condition and the specimen preparation. So thank you very much for your attention. So just I will finish this presentation in showing in sharing with you a short video that show you the system in action. And so it's an automated system, so it's more fun to see it working. And so you can see here the Xpander in action. So the system has been designed to really replace the operator. So the first thing is doing is opening the chamber, and then checking if the test station is empty. The operator has to install the specimen in the carousel in the racks, and the system is loading the specimen from the racks to the test station. So the speed here you can see is the real-time speed. It's a reduced speed to have the robot in collaborative mode and to avoid to have additional security fence around the system. But the speed can be much higher if you get some additional security fence. The interest is very limited because the loading time of the specimen compared to the duration of test is has no real influence on the productivity. So you can see here a tension mode test campaign. So the principle of the gripping system is the same. We use a vacuum cap, and here we use a spring, high stiffness spring, to ensure the clamping of the system. So the robot rotates the magazine to change the rack, and you can see how the system grip the compression test directly on the rubber with the vacuum cap. And this is a large dimension specimen, but here with a very small dimension specimen, so 5 millimeter, we have also the same capabilities. So you can see how flexible is the system and how easy is it to load the specimen in the magazine. And there is here some focus on the key point of the system. I think it's a short video, but it's something that gives a good overview. Here you have some testing data showing the superimposition of the data curve, and sometimes it's really difficult to distinguish the different repeatable tests. So that's all for me. I hope it was interesting for all attendees, and I stay available if you have any question regarding the capability of our products. Or So
excellent. Thank you very much, Hugo. It was a great presentation. I love the Xpander. It's and the video really makes it real. Huh? It is fun to see it in operation, and you get a real sense of what a powerful capability that is. Just before we stop the recording and we move to the Q&A session, I do see we have some great questions starting to stream in the chat box. I will put a plug in. Rosa, my colleague, is going to drop in a few more comments in the chat box. There's another webinar that we recorded with you about 6 weeks ago, more on general DMA, and provide some additional information. So if you're interested in checking this out, it is a recording. It's freely accessible. So we'll ask Rosa to drop that link into the chat box. I also want to plug that we have an upcoming webinar later this week just on polymers characterization, where we're going to be looking at, as well as DMA, also looking at TGA, DSC, and thermal conductivity characterization. So basically addressing what does a full lab look like for polymer characterization. So if you're interested in either of those webinars, one's already pre-recorded and you can access. The other one for the polymers, you can register for that. And even if you can't make the time scheduled, you will automatically, once you're registered, receive a link to the recording. So do encourage you to check that out. Okay, so at this point, we're going to close the formal recording. So I want to thank everyone that took the time to either participate live or reviewing this as a recording. We very much appreciate your time. We know time is in great demand these days with all we're trying to balance with the COVID situation. Many of us having to work from home, parenting, still have the job to do. So it's certainly a challenging time, and we want to wish you well and hope you're all doing very well. We're excited to have this opportunity to connect with you and would certainly welcome further discussions. If there's anything specific you'd like us to follow up, please enter in the chat box. If you'd like a quotation for budgetary purposes, you want more information, the chat box is a great place to flag that. But that said, I think we'll close the recording now and stay on the line for the Q&A.